Did you say Martin? Yes, are you there? Am I audible to you? So see how you are going to do it. There is a formula for calculating molarity of mixture, and that is for that formula is equal to molarity of mixture is equal to M1V1 plus M2V2 divided by V1 plus V2. Now you just need to recognize which one is M1 and which one is M2. So this is I'm going to take M1. So this will be your V1. And in the same way, this will be your M2, then this will be your V2. So you can see M1 is what 0.2 into V1 is 250 plus M2 is what you can see 0.5 and V2 is what you can see 100 upon V1 plus V2, that is 250 plus 100. So you just need to solve this and you will get your answer 0.2 into 250. That will be 50 plus this will be what 50 again. Okay. And you are going to add it. This will be 350. So it becomes 100 upon 350. 0 will be cancelled. It will be 10 by 35, which can be again cancelled. That is 5 7 is 35, 5 2 is 8. So it will be 2 by 7 m, or you can divide it 0.7 to the 14, and then how much if you are going to divide it 7 to the 14, then 6 left, 7 exits. So this will be the answer. So this is the formula for calculating molarity of mixture. And if you want to calculate molarity on dilution, then the formula will be M1V1 is equal to M2V2. This will be the formula for molarity on dilution. Is that clear? All of you?
Yes, sir.
Okay, can we move to the next question, Martin, Akib, and Yasir? Okay, moving to the next question. See, if I'm going to ask you how we calculate molarity of ions, this is another topic to calculate. molarity of ions. So I'm going to explain this concept with the help of a question. That is, let's say if you have 4.9 gram of H2SO4 present in, let's say, 250 centimeter cube of solution, then calculate molarity of solution. First of all, calculate molarity of solution, or H2SO4. Basically, calculate molarity of solution. We can write calculate molarity of solution. The B part, we need to calculate the molarity of ions H plus, and the C part, calculate the molarity of SO4 minus. Because you can see this is an acid which will dissociate to form, it will give H plus and SO4 minus 2. So the first question is very easy. You are going to do it in the way we did previous question. Basically this is formula based. So we are going to apply the formula. Molarity is equal to number of moles of solute upon volume of solution in liters. Now you can see number of moles of solute, that means given mass upon molar mass. Since number of moles is not directly given, so I'm going to apply the formula number of moles, that is equal to given mass upon molar mass upon volume of solution in liter. Now you can see 4.9 gram of H2SO4 is given. So here I'm going to apply 4.9 divided by molar mass. Molar mass of H2SO4, if you are going to calculate, it will be 98. And volume of solution is also given in the question. This is 250. 250. And since it is in centimeter cube, we need to convert this into liters. So we are going to divide it by 1000. So what we will get, basically 4.9 upon 98 into 1000 divided by 250. Now we are going to just simplify it. You can see 10 and 10 will be cancelled. If you are going to remove this decimal, 10 will be in denominator. Now this will be cancelled by 2 times. And this 0 and this 0 will also be cancelled. And you can see this will be cancelled by 5 times. 2 5 is 10, and this will be cancelled by 1 by 5. So the answer is 1 by 5. After decimal, you will get a 0.2. So basically, this is the molarity of H2SO4 or solution. This is the molarity of H2SO4 or solution. This you can easily apply the formula and get the answer. Is that clear? Everyone is with me up to A? Yes or no? Yasir, you are not responding at all.
Yes, sir.
Yasir? Okay. Now see, we just calculated the molarity of H2SO4, which is 0.2 m. Now, how to calculate the molarity of ions? It's very easy. Basically, if you are going to dip this H2SO4 in water, it will dissociate. Since it is an acid, it will dissociate into two parts, cation and anion. H plus plus SO4, that means sulfate is there, SO4 minus 2. Now, as you can see, 2 hydrogen is on the left hand side in H2SO4. So in order to balance it, I'm going to multiply it by 2. Because everyone knows that H2SO4 has 2 hydrogens, so it will dissociate or it will give 2H plus. Now, have you studied stoichiometry? Rishita, Martin, everyone. Have you studied?
Yes, sir.
Okay. So how do you compare with moles? Since this is the reaction should be balanced, the reaction should be balanced. So this reaction, you can still see that it is balanced. 2 hydrogen on the left, 2 hydrogen on the right, 1 S on the left, 1 S on the right, 4 oxygen on the left, 4 oxygen on the right. Atoms are all already balanced. Now, if you are going for the charge, there is no charge on the left hand side, and on the right hand side plus 2 charge. 1 H has plus 1 and there is 2 H, so it will be plus 2, and SO4 has minus 2 charge, so total charge on the right hand side is also 0. That means this reaction is balanced basically. Now, You have heard of stoichiometric coefficient, stoichiometric coefficient, right? Everyone, you have heard of stoichiometric coefficient. So what is the stoichiometric coefficient of H2SO4 here? Can anyone tell me?
2.
No. Any other?
Oh,
1 it is. H2SO4, I'm talking about H2SO4. Basically, if I'm going to ask what is the coefficient of X, that is 1. Stoichiometric coefficient, we use as stoichiometric for chemistry. In maths, you know that it is coefficient. So what is the stoichiometric coefficient of H2SO4? 1. What is the stoichiometric coefficient of H plus, Rishita?
2.
2. And what is the stoichiometric coefficient of SO4 minus 2? 1. So how we compare this in terms of mole? We compare it. This stoichiometric coefficient basically represent 1 mole. 1 mole of H2SO4 gives 2 mole of H plus and 1 mole of SO4 minus 2. This stoichiometric coefficient is very important. In the same way, we can compare this with molarity. So 1 molarity of H2SO4 will give 2 molarity of H2H plus and 1 molarity of SO4 minus 2. But actually, how much molarity of H2SO4 we have? We have 0.2 m of H2SO4. We just calculated. Okay. And you can see 1 molarity giving 2. That means twice. So 0.2 molarity of H2SO4 will give you 0.4 molarity of H plus. Again, 1 molarity of this gives you 1 molarity of SO4 minus 2, 1:1 ratio. So 0.2 molarity of H2SO4 will give 0.2 molarity of SO4 minus 2. So the answer is clear. The molarity of H plus will be 0.4 m, molarity of SO4 minus 2 will be 0.2 m. So to calculate the molarity of ions, you need to calculate the molarity of H2SO4 or the electrolyte, and accordingly, you are going to dissociate it, balance the equation, and compare with the stoichiometric coefficient, you can get the answer. Please do it. Let me know when you are done with this.
sir, I'm done.
Very good. Archive and Martin. Okay, Archive. Let me know when you are done with this. Very good. Martin, are you able to understand this? Yes or no?
Yeah, yes, sir.
Okay.
So like divide 2 mole divided by the
What divided by?
solution.
2 mole. What you are talking about? Where is 2 mole? No,
So
no, no,
in
no,
order
no,
to
no.
find the x.
This, are you talking about this?
Yeah.
No, basically, I just connected this because you have studied in stoichiometry that 1 mole of this will give you 2 mole of this and 1 mole of this. So in the same way, we can write in terms of molarity as well, right? Are you getting my point? I just connected that.
Yes, sir.
Okay. So what I was telling you, 71 gram of H2SO4 present in 250 ml of solution. Calculate molarity of A, Na2SO4, that means solution, B, Na plus, and C, SO4 minus. Very easy question. Same question almost. Not a problem. See, okay, very good, Rishita. Okay, what is the formula of molarity? That is number of moles of solute upon volume of solution in liter, right? Now, number of moles of solute, that is your Na2SO4 is the solute. As a formula, given mass upon molar mass. What is the given mass? 71. Akib, can you tell me the molar mass of Na2SO4? Yes or no? Molar mass. Will you be able to solve this? Oh, that's very bad. Sodium has 23 atomic numbers and 2 sodium is there. So I'm going to multiply it by 2. The sulfur has 32. You have to remember from 1 to 20 at least. Plus 16 is the atomic mass of oxygen and there are 4 oxygen atoms. Now you just need to simplify it. 46 plus 32 plus 64. That will come out to be 142. Now I'm going to write it 142 and you will get 1 by 2 mole because this 71 will be cancelled easily and you will get 1 by 2 mole. Now the volume is 250 ml. We need to convert this into liter. So it will be 250 divided by 1000. So you can see it will be 1 by 4 liter. Now you just need to put the value 1 by 2 upon 1 by 4. 1 by 4. That's come out to be 1 by 2 into 4 by 1. That is equal to 2 to the 4. 2 molarity. We got the answer for the A part. And the answer for the second B and C part depends upon the A part. Now, when you are going to dissociate this Na2SO4, so sodium always dissociate into Na plus. Na plus. You can write either this or directly this. Na plus. And sulfate, you know that sulfate has -2 charge. And there are 2 sodium, so you are going to write this. Now you are going to, what is the stoichiometric coefficient of Na2SO4? Akib, what is the stoichiometric coefficient of Na2SO4? What it is? 1. So we are going to directly write 1 molarity of this. What is the stoichiometric coefficient of Na plus 2? And what is the stoichiometric coefficient of SO4 -2? That is 1. So you can see 1 molarity of this will give 2 molarity doubling, and 1 molarity of this will give 1 molarity of SO4 -2. That means 1 is to 1 ratio. But originally what we have 2 molarity of this Na2SO4 actually. So if 1 will give 2, so 2 will give 4 molarity. And if 1 will give 1, so 2 will give 2 molarity of SO4 -2. So this is the answer for B and this is the answer for C. Is that clear?
Yes, sir.
Please do write it. Let me know when you are done with this. Almost. Okay. Now we are moving towards another concentration term. That is your molality. And we denote it by a small m. What is molality? So molality has a formula, that is number of moles of solute divided by mass of solvent in kg. Mass of solvent in kg. You know what is solute and what is solvent, right? And this is the only concentration term in which you use solvent in denominator. So I'm going to directly give the question. You already have studied this, right? 10 gram of calcium carbonate present in 2 kg of solvent. Calculate molality. Please do it. Any answer? Very good, Rishita. I'm going to check this. So you can see to calculate molality, it will be equal to number of moles of solute upon mass of solvent in kg. So as you can see, this is your mass given, but we need number of moles of solute. This is your solute. The one which is lesser in quantity is solvent, and this is your so the one which is lesser in quantity is solute, and the one which is greater in quantity is solvent. So as you can see, this is your, we need to calculate number of moles of solute. Again, given mass upon molar mass. Given mass is 10 gram. Akib, can you tell me what is the molar mass of calcium carbonate? Yes or no? 100 it is. So when you are going to divide it, it will be 1 by 10 mole. 1 by 10 mole. Now, mass of solvent is already given in kg. So you are going to divide 1 by 10 upon 2. So it will be 1 by 20, which comes out to be 0.05 m, a small m. You can either write 0.05. Here it is moles and here it is kg. So this will be 0.05 moles per kg. Is that clear, everyone? Okay. Now another question I'm going to give you, and that is your 46 gram of C2H5OH present in 250 gram of H2. Calculate molality. Let me know when you are done with this. Any answer from you? Okay, very good, Rishita. Very good. What about you, Martin and Yashir? So molality has a formula, number of moles of solute upon mass of solvent in kg. So again, you have to calculate the number of moles of solute that is given mass, that is 46 gram. And if you are going to calculate the molar mass, that will be 46. So number of moles of solute is 1 mole. And mass of solvent, you can see, is very easy. Mass of solvent, that is equal to 250 gram. And you need to convert this into kg. So we just divide it by 1000 to convert this into kg, and this will be 1 by 4 kg. So number of moles of solute is 1, and this will be 1 by 4. So it will directly come here. It becomes 4 moles per kg, or 4 m. Very easy it is, right? So now I'm going to give you another question, and that is 46% weight by weight C2H5OH in aqueous solution. I hope everyone knows what aqueous solution means, right?
Yes.
Calculate molality. Very good, Rishita. Calculate molality. Yes, the question is very easy. When the examiner wants to make tough question, so they will use weight by weight or weight by volume. What does this mean? 46 gram of solute. This is for solute. And since W, so we use gram solute. And solute here is your C2H5OH present in percent, that means 100, and this is for solution, and weight is there, so it will be 100 gram of solution. Now will you be able to solve this? I just gave you hints. Let me know when you are done with this. Okay, let's see. I'm going to explain my answer. Very good, Rishita. So you can see solute mass is given, and here, just wait a minute. And here you can see mass of solution is given. You know that solute plus solvent is equal to solution. So mass of solution is 100 gram, and mass of solute is what, 46 gram. So here the mass of solvent will be equal to, you can see mass of solvent will be equal to 100 minus 46, that is 54 gram. Now going to apply the formula, molality is equal to number of moles of solute upon mass of solvent in kg. Now mass is given, not directly molality, number of moles. So this is given mass 46 upon molar mass 46 divided by mass of solvent is 54 grams. So we need to divide it by 1000 to convert this into kg. Very simple. So just need to simplify it, 46 by 46 into 1000 by 54. Now you just need to cancel this, and this will be cancelled by 500 by 27, and the answer will be 500 by 27 m. You can also convert this into decimal. Have you got it, Rishita?
Yes, sir.
Okay, please do it. Let me know when you are done with this.
Sir, I'm done.
Sorry. This is for homework. And this is the same question like the previous one. And please do complete normality. In the next class, we are going to complete this normality. These are some basic terms or the concept which will be used in physical chemistry, almost every chapter. So I will recommend you to please do this question as please do understand the concept. Very important topic these are. Let me know when you are done with this question. Okay, are you done with this question?